Man, why didn't I study gravitational potential energy for that exam? Someone kill me! I didn't mean it literally.
He's fine. And hello, once again. We apologize sincerely for not being able to do another video, guys. Our last one was kinetic energy. It's been a long time. We've been busy with school and stuff. Although it's not an excuse, we promise such a thing won't happen again.
Okay, so let's think more cheerful thought and move on to the wonders of physics with student 2, student 4, that's me. Gravitational potential energy.
First of all, there's a couple of words there we really know. First of all, everyone knows what energy is. If you don't, just flip back to our first video. Potential energy. Student 4?
Well, okay. Potential energy, as you can see on our official definition slide of the board here, it is the energy that is stored in an object. For example, this marker has energy stored in it. Okay?
Good. Now, what about gravitational potential energy? Well, that is the energy stored in an object due to its position above a surface.
Like this.
So, this marker has energy relative to this surface.
It is exactly 1 meter above this surface of the desk, which means that however much energy it is that's stored in this is proportionate to the 1 meter distance that it is off the desk. Now I drop it, and the potential energy is gone.
It has potential. You heard when a teacher says, oh, you have the potential to do this. You have that in you. You just got to let it out. That's what gravitational potential energy is.
I never heard that.
Oh. Now, we're going to teach you how to calculate this value using this formula.
Eg equals mg delta h. So this delta, this weird looking triangle over here might throw you off. It simply means the change in, as student 2 will now explain.
Delta h, change in height, the final height minus the initial height, or h2 minus h1, whatever you want to do there. That's probably something you should keep it tucked away in the back of your mind just in case to calculate a couple things. Now, what about the units for this, student 2?
Well, okay. So mass, as we all know, is measured in kilograms.
Always kilograms. If it's grams, change it.
Yeah, like divided by 1,000, okay? The conversion from grams to kilograms is divided by 1,000 because there's 8,000 grams in 1 kilogram. So if you have a kilogram and then for your final answer, but you're supposed to answer in grams, please multiply by 8,000.
Please.
Please. Like, do it for us if you have to.
What's this g over here?
That is the gravitational constant, which is measured in most places around the world as 9.8 meters per second squared. This value will change depending on where you are, but not by very much. It is always 9.79 something to 9.82 something.
Your teacher might use 10 just to round it off to a nice whole number, but
like, just do what
you get the picture, right? You can see this little diagram we have over here drawn. This boulder is falling on this man thinking happy thoughts. This boulder has gravitational potential energy. That energy is being let out. Now,
hold on, student 2. We forgot the units for height.
Oh my god.
Like seriously, this is the kind of mistake you don't want to make on a test.
You never want to jump to conclusions.
You get a height value of, a delta H value of 102 centimeters. Well, you have to convert that into meters. Which, you know, everyone knows there's 100 centimeters to a meter, so 102 centimeters is actually 1.02 meters. Okay,
there you go. So the units for gravitational potential energy would just be joules, like all other energy.
Okay, so now we have the sample problem that we've prepared for you guys. Student 2.
A 400 kilogram anvil is sitting on a desk. I don't know why you would have an anvil on your desk. Don't ask me.
Maybe you're Wile E. Coyote trying to catch the Roid Runner. I don't know, okay?
Whatever. Anyways, it's on your desk. It's 1.2 meters off the floor when it's sitting on your desk. What is the gravitational potential energy with respect to the desk and the floor? Oh, okay, let's start off with the desk. Let's pretend this is my anvil. There's my anvil, sitting on the desk.
1.2 meters is up here. Let's say this is the anvil, way up here at 1.2 meters.
Okay, let's say that.
I like to be exact, okay?
Sorry. Here's the surface. What energy do you think that anvil is going to have relative to this surface?
If you answered 0, joules, then you are absolutely correct.
You are correct. Why, students?
Okay, well, let's look at this equation. So mg delta h, they're all being multiplied together. So if the delta h is 0, h2 and h1 are the exact same, then of course the final answer is 0 because anything multiplied by 0, however many times you multiply it, will always equal to 0. Okay?
Simple math. You guys know that.
Yeah, so if your teacher gives you like a problem that says the delta h is 0 or you calculate it to be 0, then you can simply write final answer is 0 joules.
So therefore, the gravitational potential energy of this anvil, ignoring 1.2 and 400, relative to the desk, it is 0 joules.
Okay, so let's...
Orange juice, if you will.
OJ, oh, that's perfect, but let's not go OJ Simpson. Okay, so let's get back to this desk of ours that's so tall. So,
with respect to the floor now.
This floor, we have 1.2 meters of separation in height. This means that no matter what the final answer is, it's always proportional to 1.2 meters. So let's set up the equation.
Absolutely.
G equals mg
Delta height, the change in height.
Okay, so we have our delta h.
It's given to us. Don't need to worry about calculating that.
So, what is our mass?
Oh, I got a 400 kilogram mass.
That's pretty heavy. I wonder how they got it up there. Oh, yeah, it's heavy for me. Come on. Okay, the gravitational constant is
9.8 for this video
meters
sake.
per second. The delta height, as I've circled, is 1.2 meters.
Oh, you forgot second squared, student 4.
You're defacing my work, but I'll let it slide. Okay, yeah, please don't forget, like, to square anything or to square root.
Don't forget
okay?
units.
Like, you have to remember this kind of stuff, guys. Like, that cost me big marks on my test. I don't want it happening to anyone else, okay?
No one wants to lose marks. So you see, got all these values here with nice and easy units.
You just substitute it in.
Plug and play, pause the video, whatever you get, let us know.
Okay,
so, if you calculated this, you should get 4,704 joules.
4,704
joules. That's the potential, the energy stored in this anvil with respect to the floor.
Yeah, that's actually a lot of energy. Do not leave your hand under there in any circumstances. Okay, like if you play the piano or something, there goes your career. Okay, well that's it for today, guys. I hope to be uploading another couple videos soon.
For sure.
Like, oh yeah, and Christmas is coming, or if you don't celebrate Christmas, the winter break from school.
Happy holidays, you're off school.
Yeah, you know, like ho ho ho, go see Santa at the mall.
Everyone's gonna do physics, right? Right.
Study up in physics for that exam. Capiche? Dismissed.